Now we're going to learn how to add, subtract, and multiply polynomials. To add polynomials is really easy because all we have to do is eliminate the parentheses and combine like terms. So 7x plus 6, the parentheses are really there to say this is one polynomial, plus here's another polynomial. But a plus sign outside parentheses doesn't change anything. So this is the same as just having the list of terms, 7x plus 6 plus 4x minus 7. And just like we've practiced previously, we look for like terms and we combine those. The terms that have x's follow the sign rules. 7x plus 4x makes a total of 11x. Look for the terms that do not have an x, my constants, and I have a positive 6 minus 7. If I add those up, I end up with negative 1. So 7x plus 6 plus 4x minus 7 gives me a total of 11x minus 1 once all my like terms are combined. Now if I subtract, it's a little bit more difficult. This first set of parentheses, I've got nothing in front of them. So to get rid of those parentheses, I just drop them. 9x minus 2. But we just learned a negative outside of parentheses, that has to be distributed. Either the negative or negative 1 has to get multiplied by both of the terms inside the second parenthesis. So negative times positive is going to be negative 4x. Negative times positive is going to be negative 5. So you can't disregard a negative outside of parentheses like you can a positive. You must distribute the negative to get rid of the parentheses. Now once I've made those sign changes, I'm just combining like terms with the signs that I have. So 9x minus 4x is 5x. Negative 2 minus 5 makes a total of negative 7. Now if I want to multiply polynomials, I have a couple of different scenarios that I have to worry about. We just learned the first one. If I have one term outside parentheses, I just distribute. Same as the last section. So 3 times 4 is 12. X times x squared is x to the third. Positive times negative is negative. 3 times 5 is 15. X times x is x squared. Positive 3 times positive 2 is positive 6. I don't have any other variables, but I do keep my x. Since everybody's got an x, I stop and take another look. None of my exponents match, so none of my terms are going to combine, and that's my final answer. Now what happens if I have a polynomial times another polynomial, which means I have more than one term times more than one term? In this case, I've got 2 terms times 2 terms. I'm going to distribute not once but twice. First, I'm going to take 2x and I'm going to distribute it here. Now to show you what that would look like, I'm going to take 2x times 3x plus 5 and I'm going to get that answer. But that's only half of what I wanted to multiply times the 3x plus 5. I also want to take positive 6 and multiply it by 3x plus 5. Both of those terms get multiplied by 3x plus 5 separately. I distribute here. 2 times 3 is 6. X times x is x squared. 2 times positive 5 is positive 10. Now I'm going to keep my x. Positive 6 times positive 3 is going to be positive 18. Don't lose the x that was with the 3. Positive 6 times positive 5 is positive 30. Now I go looking for like terms, and this time I actually do have some. 6x is not a like term for anyone, but I do have two terms that have an x. 10x and 18x make a total of 28x's plus 30. And that's my final answer. Now there's nothing wrong with writing out the problem that we just did as distributing twice. There's another method called the FOIL method that some people use as kind of a shortcut. FOIL is an acronym. It stands for first, outer, inner, and last. Now what we mean by those things, if I look at my polynomial, 2x and 3x, those are my two first terms. And if I do 2x times 3x, I get 6x squared. Outer, that's that. My two outside terms. That would be 2x times 5, which would be 10x. I stands for inner. That's these two guys in the middle on the inside. 6 times 3x is 18x. And last is the last term in each polynomial. So these two. 6 times 5 is 30. Now, if I examine those for like terms as I write that out as a regular polynomial, 6x squared does not combine with anything. I've got a 10x and an 18x, which are the same, so that's a total of 28x plus 30. Now what you'd like to be able to do is not really write that out, but use that acronym to help you work the problem right here. First, 2 times 3 is 6, x times x is x squared. Outside, 10x. Inside, 18x. And last, and the acronym just helps you remember to multiply each of those combinations rather than to write out the double distributive kind of problem. Now what do I do if I have a polynomial with a square on it? Well, if I have a square on the outside of parentheses, not just on the x or on one term, that means I need one of these multiplied by another one of those. That means 4x plus 1, times another 4x plus 1. Now I could do that any of the ways that I just showed you before. If I want to, I could take 4x times 4x plus 1 plus 1 times 4x plus 1. 4 times 4 is 16. X times x is x squared. 4x times 1 is 4x. Over here, 1 times 4x is just 4x. And 1 times 1 is 1. Like terms, I would get 16x squared plus 8x plus 1. Now if I want to come over here, if I want to try to do the FOIL method, makes you do a little more in your head, not write out as much. First, 4 times 4 is 16, x times x is x squared. Outer, inner. Now last, same like terms. No matter which way I do the problem, I should get the same answer, because 4x plus 1 times 4x plus 1 only has one answer. Choose one of your methods and get good at it. Whichever one you get good at, that's the one you're pretty much going to have to stick with. This one takes a little bit more work mentally, but once you have the pattern, it'll actually go quicker than this one. If you're not a person who gets in a hurry, and if you don't mind writing things down and being precise, the first way is the most efficient way to keep track of everything.